PolySet APRJC 2022 most important bits from the electric current chapter physics part students for APRJC and PolySet. So electric current chapter is the most weighted chapter. So at least 6 bits we can expect from this chapter. So helpful to get 40 out of 40 in PolySet 2022. First question. Sum of the two resistors is 6 ohms and their equivalent resistance when connected in parallel is 1.5 ohm. Then the product of two resistors. So let it R1 R2 are taken as two resistors. So sum of two resistors is a given. R1 plus R2 is 6 ohms students. When they are connected in parallel, resultant resistance R is a given 1.5 ohm. Then we want to find a product of two resistors. Product means multiplication. So R1 into R2 value we want to find. We know that in parallel combination, equivalent resistance 1 by R is equals to 1 by R1 plus 1 by R2. So by the simplification we can get R1 plus R2 by R1 into R2. This is the formula. Now 1 by R we are taking a reciprocal R by 1. Then this will be R1 into R2 by R1 plus R2. That is 1 by R is written as R by 1. Then it is also reversed reciprocal. So this implies R is equal, R by 1 means R. R is equals to R1 into R2 by R1 plus R2. But R1 plus R2 is a given. R value is a given. We want to find R1. So this implies R value students 1.5 R1 into R2 by R1 plus R2 6. So this implies R1 into R2 is equals to 1.5 into 6, that is 9 ohms students. So option is this is. Next question number 2, 6 joule by 2 coulomb. We know that 1 volt is equals to 1 joule per coulomb. That is 1 joule per coulomb. From the definition of potential difference equal to work done by charge. So potential difference unit is volt, work unit is joule, charge unit is coulomb. So this is 6 joule per 2 coulomb. That is cancellation 2 1s 2 3s. That is 3 joule per coulomb. But you know 1 joule per coulomb is equals to 1 volt. That is why option is 3 volts students. This is the option 3 volts. Next question number 3. A charge of 6 coulomb, charge is a given, Q is 6 coulombs, is flowing through the point in a circuit for 2 minutes, time is a given 2 minutes. Then we want to find current value students, is a question mark. But 2 minutes means 120 seconds. 120 seconds. We know the definition of current. Rate of flow of charge is called current. Current is denoted by I. I is equals to Q by T. That is 6 by 120. That is 6 20s. That is 1 by 20. 1 by 20 means 0.05 amperes. This is. Pick out the correct answer from the following statements. Kirchhoff's junction law is based on law of conservation of charge. It is right. Kirchhoff's loop law is based on law of conservation of energy. Both are true. Both A and B are true. It is Kirchhoff's first law. It is Kirchhoff's second law. Question number 5 students. Question number 5. The resistance of a wire of length is a given students. L is 1 meter. Cross sectional area is a given 1 mm square. That is 1 mm square is equals to 10 power minus 6 meter square. So conversion of millimeter square into meter square students. 10 power minus 6. meter square, and resistance is given R is 1 ohm. Now we want to find specific resistance. So we have a formula, resistance R is equals to rho L by A. This is called rho, which is called specific resistance. Then rho is equals to RA by L. R value is a 1 ohm, A value is a 10 power minus 6, L value is a 1. That is 10 power minus 6 ohm meter. So this is the option, students. This is option. Next, question number 6. Which of the following pair of devices measure the same physical quantity? So ammeter and galvanometer, so both are useful in measuring the strength of the current. Generally, galvanometer is used to detect the presence of electric current. It is also used to measure small amounts of current. So ammeter and galvanometer are used to measure the same physical quantity. That physical quantity is electric current. Lenzula gives, actually Lenzula is taken from electromagnetism chapter, students, but not electric current. So but this, for this academic year, so this chapter is eliminated. So what is a Lenzula? Lenzula gives a direction of induced current. Current produced in electromagnetic induction called induced current. Its direction is given by Lenz law. Next to question number 8 also from the same chapter, students. So you can see a force exerted on a 3 meter long conductor. L is 3 meters. Having a current of I is 2 amperes. And magnetic field induction B is 0.4 Tesla. And theta is 30 degrees. Then we want to find force acting on the conductor, on the current carrying conductor. But in this case we have a formula, F is equals to ILB sin theta. I value is 2, L value is 3 meters, B is 0.4. So sin 30 degrees, theta is sin 30. So formula is ILB sin theta. So that is 6 into, this will be 2 into 3 into 0.4 into sin 30 means 1 by 2, students. That is 0.1, 2 0.2s. That is 6 into 0.2. That is 1.2, students. So this is the force acting on the current carrying conductor. So it is also bit from electromagnetism. Question number 9. Which among the following does not involve in the principle of electromagnetic induction? It is also from electromagnetism chapter. Electric motor, electric generator, electric greaser, induction stove. Electric greaser is not involving in the principle of electromagnetic induction. Question number 10, students. A house has one bulb and power is 100 and working for 10 hours a day. The cost of electric energy for a electric bulb for 30 days. So first we want to calculate number of kilowatt hours of electrical energy for a month of 30 days. That is number of bulbs into power of each bulb into time of working per day into 30 by 1000, students. It is a formula. Number of bulbs only one. Power is 100 watts. Time of working per day is 10 hours. For how many days? 30 days into 30 by 1000. 0, 0, 0, 0, 0, 0. On cancellation 10 into 3, we can get 30 kilowatt hours of electrical energy is used by one bulb for 30 days on working average of 10 hours. But 1 kilowatt hour rate is a given, that is 3 rupees. That is total cost is 30 into 3 rupees, that is 90 rupees. So this is the option, students, 90 rupees. Rupees 90. Next. 4 wires of each resistance 8 ohms are arranged in the form of square. So in the form of square, students, you can see 8 ohms, 8 ohms, 8 ohms, 8 ohms. 8 ohms. Now the resistance between the ends of any two diagonals. So now between these two or these two. Now I am going to find between these two ends. It is A and EB. So what is? Now these two will be in series, these two will be in parallel. On combining it is 16 ohms. On combining it will be 16 ohms. Now 16 and 16 are in parallel. So 1 by R is equals to 1 by 16 plus 1 by 16. Then 1 by R is equals to LCM is 16 students. 1 plus 1, that is 2 by 16. So 1 by R is equals to cancellation, 2 ones, 2 eights. So now we want to only R but not 1 by R. So 1 by R means R by 1 is written, then it will be 8 by 1. So resistance is 8 ohms. So it is a answer, students. So you can see here between A and B, what is the total resistance we want to find. Then this is a one wire. So this is a one wire, 8 ohms and 8 ohms are in series, on summation 16. 8 and 8 are here series and on summation 16. Now 16 and 16 will be in parallel. That is why this formula is used. So 2 volt into 3 coulombs. We know that 1 volt is equals to joule by coulomb. Then joule is equals to volt into coulomb. Joule is equals to volt into coulomb. That is 2 into 3, 6. It is a 6 joules. Because volt into coulomb equal to joule. Next. Which among the following materials have resistivity of 10 power 10 at ohm meter at 20 degree Celsius? But here you can see, students, resistivity value 10 power plus 10. It means that higher it must be not for lead, not for copper, because these two are metals. They have specific resistance in negative exponents. But air has a 1.30 into 10 power minus 16. So answer is a glass. Answer is glass. Next, pick out the correct one from the following state. Human skin offers more electric resistance than organs inside. Human body offers common electric resistance of 10 lakh ohm always. So it is wrong. Human skin offers more electric resistance than internal organs. This is right. Only A is true. But human body has a resistance from 100 ohms to 5 lakhs ohms. So but here it is this value. It is not correct. The resistance of wire of length 100 centimeter, area of cross section 1 millimeter square and 1 ohm. Same formula, students. Length is a given. Already we solved this problem. Length is 100 centimeter means 1 meter. And area means 1 millimeter square, which is equal to 10 power minus 6 square meters. And resistance value is 1 ohm. So we want to find specific resistance. Rho is equals to RA by L, students. R value 1, A value 10 power minus 6, L is 1. That is 10 power minus 6 ohm meter. So answer is this is, students. 1 millimeter square is equals to 10 power minus 6 square meters or meter square, students. Question number 16. The graph between potential difference taken on x-axis and current taken on y-axis for an iron spoke is constant at constant temperature gives. So you know iron spoke, it is a metal which is a ohmic conductor which follows Ohm's law. So it is also called a linear conductor or ohmic conductor. That is why, so it is a this graph gives like this, students. It is a potential difference V and it is current. The graph is this is like this. So x-axis, y-axis, straight line passing through origin. It is origin. Straight line passing through origin. So the resistance of a material depends on its temperature, length, cross-sectional area. So all the above. So resistance of a material depends on temperature, length of the conductor, cross-sectional area of the conductor, and also nature of material. Next, if a charge is Q moving against electric force Fe through a distance d, then between the terminals EMF E is. So EMF is also equal to work done by charge, but you know work equal to force into distance, but this force is this work done equal to F into S by Q, but F is here electric force and S means distance given D, F E D by Q. This is the formula for electric, that is electromotive force. Next question. Question number 19 students. Two resistors of values X and R1 is X, R2 is X by 2 connected in parallel, then combination, what is the effective resistance? In the parallel combination we have a formula 1 by R1 plus 1 by R2, that is 1 by X plus 1 by X by 2, that is 1 by X plus 2 by X, then it will be LCM is X and 1 plus 2, so 1 by R is equals to 3 by X, but we want R but not 1 by R, that is why reciprocal is taken. 1 by R is written as R by 1, then it will be X by 3, so R is equals to X by 3, this is X by 3, it is the answer students. Next, an electric bulb is marked at 40 watts and 120 volts, it means that in 1 second it converts. You know electric power P is equals to W by T, SI unit of P is watt, 1 watt is equals to work done unit joule and time is second. So 1 watt is equals to 1 joule per second. 40 watts means 40 joules of electrical energy is converted into heat and light in 1 second. So 40 joules of electrical energy is converted into heat or light in 1 second. The quantity which has SI unit as a coulomb. So you know SI unit for electric charge is a coulomb. It is denoted by the letter C. The filament of an electric bulb is usually made of tungsten. Its symbol is W, Latin name is wolfram. Its melting point is 3422 degrees Celsius. Due to high melting point of this metal, it is used as a filament in the electric bulb. Joule per coulomb is, joule per coulomb students, we know potential difference equal to work done by charge. So SI unit of potential difference is volt, SI unit of work done is joule, SI unit of charge is coulomb. So joule per coulomb equal to volt. So it is 1 volt. Next question. The drift velocity of electron in the copper wire is about 0.07 millimeter per second, or 7 into 10 power minus 5 meters per second, or it is a 0.07 millimeter per second. Drift velocity. The constant average velocity of electrons in the metal or conductor is called drift velocity or drift speed. Next question. So 3 resistors of each value 3 are connected in parallel, their equivalent resistance. R1 is 3 ohms, R2 is 3 ohms, R3 is 3 ohms. All are connected in parallel. We want to find the resultant resistance. We know in parallel combination 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Then 1 by 3 plus 1 by 3 plus 1 by 3. LCM is 3, then it will be 1 by 1. Then R by 1 is equals to 1 by 1, that is 1 ohm. So it is the answer students. Next. At constant temperature, the ratio of potential difference and current is not a constant. Constant means Ohm's law is being followed. They are called ohmic conductors. Example for ohmic conductors, metals like iron, copper, aluminium. But here not constant means it is not a following Ohm's law. It is a non-ohmic conductor. So non-ohmic conductor is LED. In the case of LED, so we cannot prove that V by I is constant. So that is why here ratio of potential difference and current is not constant means it is not obeying Ohm's law. It is not obeying Ohm's law. So this is example for non-ohmic conductor. Next, a bulb of resistance 200 ohms connected to 10 volt battery, that is potential difference V is 10 volts given. Then we want to find power conjunction P. But we have a power is equals to V square by R students, that is 10 square by 200. So 10 square means 100. 100 by 200. 0, 0, that is 1 by 2. 1 by 2 means 0.5 watts. This is. Next question. The product of potential difference and current gives. The product of potential difference and current, students. We have a formula from Ohm's law. V directly proportional to I. Then V is equals to IR, students. So the product of potential difference and current gives. So related to power, using Ohm's law and power is equals to W by T, we can get power, students. You can see the derivation. P equal to W by T. From potential difference, it is written as V is equals to W by Q. V equal to W by Q, then W is equals to VQ. It can be written as V into Q by T. P equal to V into Q by T. But you know from current definition, I is equals to Q by T, then Q is equals to I into T. Substitute here, power is equals to V into IT by T. T cancel, that is V into I. So this is equal to P, students. So electric power, answer is electric power, students. Pick out the correct answer from the following statements. Semiconductors obey Ohm's law. Semiconductors do not obey Ohm's law because they are non-ohmic conductor. Metallic conductors obey Ohm's law, so it is right. So only B is true. Next. Which among the following materials have resistivity values in order from 10 power 14 to 10 power 16? It is positive, students. Highest resistivity for only insulators. This range is for insulators. 3 resistors of each 3 ohms are connected in parallel combination. Equivalent resistance is 1 ohm. In the previous case, we solved this problem, students. You can see in the previous questions. Next question, 32 question number. Question number 32. A metallic bulb of 360 ohms. R is a given. R is a 360 ohms. Are connected into potential difference. PD is V is equals to 6 volt battery. Then we want to find power, students. So we have a formula, P is equals to V square by R. So V square means 6 whole square by R means 360. That is 36 by 360. 36 ones, 36 tens. That is 1 by 10. 1 by 10 means 0.1 watts, students. So on this formula, most important problem, definitely one problem will come in Polytechnic entrance examination and also APRJC examination. So from physics, P is equals to V square by R formula, students. Next one, which of the following statement is true? Resistance of a conductor is true. Resistance of a conductor is independent of its length. So it is not true because resistance depends on length. Resistance of a conductor is directly proportional to its length. It is true. It is true. Next one, resistance of a conductor inversely proportional to its length. It is wrong. Resistance of a conductor is independent of its temperature. It is also wrong. So option is 2, students. So in the next video from chemistry part, that is chemical bond, we upload 20 more bits. After that, final touch, 40 bits from physics and 30 bits from chemistry will be uploaded, most important bits. So in within 2 days, students.